So my dear student, my second video is related to the concentration unit. So topic is expressing concentration of solution. So first concentration unit to measure the concentration of a solution is mass percentage, also known as by mass of solution and denoted by symbol of W by W. So mass percentage of a component in a solution is equal to mass of the component divided by total mass of solution, and whole relation is multiplied by 100 to convert into percentage. So this is the mathematical relation. This is the mathematical relation to find out mass percentage of any component in a solution. Component means solute and solvent for a binary solution. So to explain about the mass percentage, let us consider a solution which concentration given in mass percentage, suppose 10% W by W solution, 10% W by W solution. So in this solution, 100 gram of this solution is containing 10 gram of solute and another 90 gram of solvent. That means 100 gram solution is containing only 10 gram of solute and how many gram of solvent? 90 gram of solvent. So 10 gram of solute plus 90 gram of solvent equal to 100 gram of the solution. One more solution is 5% W by W solution. So 100 gram of the solution is containing 5 gram of solute and 95 gram of solvent. So 5 gram of solute plus 95 gram of solvent equal to 100. How many gram of solution? 100 gram of solution. So from the mass percentage, we have 100 gram of a solution is containing how many gram of solute and how many gram of solvent. So mass percentage provides the information 100 gram of a solution is containing how many gram of solute and how many gram of solution. So next one concentration unit to measure the concentration of a solution is volume percentage, also known as by volume of the solution and denoted by the symbol of V by V. So volume percentage of any component in a solution is equal to volume of the component divided by total volume of solution multiplied by 100. So this is the mathematical relation to find out volume percentage of any component in a solution. So let us consider an example. Let us consider a solution which concentration 10% volume by volume. So 100 milliliter of the solution, volume of the solution is 100 milliliter. 100 milliliter of the solution is containing 10 milliliter of solute and another 90 milliliter of solvent. So 90 milliliter solvent plus 10 milliliter of solute equal to 100 milliliter of the solution. So one more solution, 5% volume by volume solution. So volume of the solution is 100 milliliter. In 100 milliliter solution, 5 milliliter solute is present and another 95 milliliter of solvent is present. So volume percentage provides the amount of solute and solvent in milliliter in 100 milliliter of a solution. 100 milliliter solution में कितना milliliter solute, कितना milliliter solvent and कितना milliliter solute it is provided by the volume percentage. One more concentration unit to measure the concentration of a solution is mass by volume percentage, denoted by the symbol of W by V percent. So it can be defined as, it is defined as the mass of a solute in gram is present in 100 milliliter of a solution. It is defined as the mass of a solute in gram is present in 100 milliliter of a solution. That means 100 milliliter solution में जितना ग्राम सोल्यूट होगा that is known as mass by volume percentage of a solution. So let us consider a solution which concentration 10% W by V. So 100 milliliter of this solution is containing 10 gram of solute only. In this solution 100 milliliter solution में कितना ग्राम solute है? 10 gram solute है. So one more concentration unit to measure the concentration of a solution is parts per million. It is a concentration unit. It is used to measure very trace quantity of chemical substances. So parts per million of a component in a solution is equal to number of parts of the component divided by total number of parts of all the components, and relation is multiplied by 10 to the power 6. So this is the relation to find out parts per million of a component in a solution. So parts per million of a component in a solution equal to number of parts of the component divided by total number of parts of all the components, and whole relation you have to multiply it by 10 to the power 6. So it is a concentration unit. It is used to measure very small quantity of the chemical substances. One more very important concentration unit, that is mole fraction, denoted by X. So the mole fraction of a component in a solution is the ratio of individual moles of the component to the total number of moles. So mole fraction of a component, mole fraction of a component in a solution is the ratio of individual number of moles of the component to the total number of moles. That means particular X solution में particular to measure the mole fraction of a particular component, then individual moles of the component we have to divide it by total number of moles. To explain about it, let us consider a solution. Let us consider a binary solution in which two components are present, component A and component B. Let us consider number of moles of component A in this solution Na, and number of moles of component B is Nb. So how can you calculate Na? Number of moles of component A, how can you calculate? Number of moles of component A you can calculate by dividing weight of the component A by the molecular mass of the component A. Similarly, number of moles of component B, how can you calculate? By dividing weight of the component B divided by molecular mass of the component B. So for this solution, mole fraction for the component A, XA is the mole fraction for the component A, equal to individual moles of component A in this solution divided by total number of moles. Total number of moles Na plus Nb. Similarly, mole fraction for the component B, XB, equal to individual moles of the component B divided by the total number of moles. Now XA plus XB. So XA equal to Na divided by Na plus Nb, plus XB equal to Nb divided by Na plus Nb. Na plus Nb taking LCM, then this is equal to how many? 1. So XA plus XB always equal to 1. That means sum of the mole fractions of two components in a solution is equal to how many? 1. In general, sum of the mole fractions of all the components in a solution is equal to how many? 1. So one more concentration unit to measure the concentration of a solution is molarity, denoted by capital M, or it is also known as moles per liter. So molarity, it is defined as the number of moles of a solute dissolves in per liter of solution. It is defined as the number of moles of a solute dissolves in per liter of a solution. The mathematical relation to find out molarity equal to number of moles of solute divided by volume of solution in liter. हम लोग लीटर को मिलीलीटर में कन्वर्ट कर देने से रिलेशन वी हैव टू मल्टीप्लाइड बाय 1000. So in place of number of moles of solute we can write weight of the solute divided by molar mass of solute. number of moles of solute we can calculate by dividing weight of the solute by the molar mass of the solute. So in place of number of moles of solute equal to weight of solute divided by molar mass of solute, then volume of solution in milliliter, so relation is multiplied by 1000. So so let us consider a solution which concentration given in molarity 0.1 molar solution. So what is the meaning of it? 0.1 mole of solute is present in 1 liter of a solution. Similarly, 0.001 molar solution means that 0.001 mole of solute is present in 1 liter of a solution. So one more very important concentration unit is molality, denoted by small m. Moles per kilogram is the symbol for it. It is defined as the number of moles of a solute is dissolves in 1 kilogram of a solvent. तो 1 किलोग्राम सॉल्वेंट में जितना मोल सॉल्यूट होता है दैट इज द मोलैलिटी. बट 1 लीटर सॉल्यूशन में जितना मोल सॉल्यूट होता है दैट इज द मोलरिटी. सो मोलरिटी इज रिलेटेड टू वॉल्यूम ऑफ सॉल्यूशन and molality is related to the weight of the solvent. So relation to find out molality equal to number of moles of solute dissolves in per kilogram of the solvent. So molality equal to number of moles of solute divided by weight of solvent in kilogram. So this is the mathematical relation to find out molality. This is weight of solute divided by molar mass of solute. So relation is multiplied by 1000. So weight of the solvent in gram. So this is the mathematical relation to find out molality or mole concentration of a solution. So let us consider a solution which concentration given in molality 0.1 molal solution. That means 0.1 mole of solute is present in 1 kilogram of solvent. So 1 kilogram solvent में कितना मोल सोल्यूट है? 0.1 मोल सोल्यूट है in 0.1 molal solution. So molality is temperature independent, whereas molarity is temperature dependent, because molarity is related to the volume of solution which varies with temperature. So molality temperature independent, whereas molarity temperature dependent. Why molarity temperature dependent? Because molarity is related to volume of solution and volume varies with temperature. And one more concentration unit, that is normality. It is not mentioned in your textbook, but it is important for entrance examination. That is normality, denoted by capital N. It is the number of gram equivalent weight of solute is present in per liter of solution. Per liter solution में, that means 1 liter solution में जितना numbers of gram equivalent weight of solute होता है, that is called the normality. So normality equal to number of gram equivalent weight of solute divided by volume of the solution in liter. So how can you calculate number of gram equivalent weight of the solute? To calculate the number of gram equivalent weight of solute, you have to divide it weight of solute by the equivalent weight of solute. By dividing weight of the solute by the equivalent weight of solute, you can calculate number of gram equivalent weight of solute. So this is the second relation to calculate the normality. So weight of the solute divided by equivalent weight of solute, relation is multiplied by 1000, then volume of the solution becomes in milliliter. So it is the mathematical relation to find out normality, that means concentration in normal. Normality also shortly known as normal. So now question is, how can you calculate equivalent weight of a solute? Equivalent weight of an acid, how can you calculate? By dividing molar mass of acid by the basicity. Basicity means number of replaceable proton in an acid is called basicity. So let us calculate the equivalent weight of sulfuric acid. Sulfuric acid Basicity for sulfuric acid is 2 because it has 2 replaceable proton. So equivalent weight of sulfuric acid, its molecular mass 98 divided by its basicity 2, then equal to how many gram? 49 gram. So 49 gram is the equivalent weight of sulfuric acid. Similarly, equivalent weight of a base, how can we calculate? By dividing molecular mass of the base by the acidity. Acidity means number of replaceable hydroxyl ion in a base or alkali. Okay? Acidity means number of replaceable hydroxyl ion in a base. For example, equivalent weight of sodium hydroxide. Sodium hydroxide, it has acidity is equal to 1 because it has only one replaceable hydroxyl ion. So equivalent weight of sodium hydroxide equal to its molecular mass 40 divided by acidity 1 equal to how many gram? 40 gram. So equivalent weight of a salt, how can we calculate? Equivalent weight of a salt equal to molecular mass of the salt divided by valency of metal atom. So equivalent weight of a salt, molecular mass of the salt divided by valency of metal atom. So sodium carbonate, it is a salt. So equivalent weight of sodium carbonate equal to molecular mass of sodium carbonate 106 and valency of sodium is 1. But sodium carbonate is containing 2 sodium. Therefore 1 is multiplied by 2, then 53 gram. So 53 gram is the equivalent weight of the sodium carbonate. So my dear student, these are the concentration unit. You have to note down all this concentration unit in your copy. In the next video, we will solve few numericals related to the concentration unit. Thank you.